cut and edit a little bit. Maybe let's just start from the introduction a little bit.
Sure.
My name is Munoz. I'm from Monash University and studying consciousness from a neuroscientific point of view, but also interested in the interdisciplinary research.
Okay, my name is Milagu. I'm a faculty at the Nanyang Technological University from the School of Mathematics and Physical Sciences. And my background specialized in quantum information theory and a little bit of complexity as well.
My name is Kavan. I'm also from Monash University. I'm a physicist, quantum information theorist for the most part, but I'm also interested in ideas of agency, consciousness, and how they're related to complexity, causality, etc.
Okay, so maybe let me propose to start with a brief introduction of how we met, right? Probably. So that everything started with me and Kavan giving a talk at Monash. It was called probably Math in the Fame or something, right?
Maxima seminar.
Maxima seminar.
Yeah.
It's basically mathematics department leading some kind of seminar, collecting the faculty from all the different fields. And then it just happened to be the case that I gave the first talk and the Kavan gave the second talk all that same day. And then I talked about integrated information theory of consciousness at that time, which is kind of related to the causal analysis of the relationships among the entities. And then after that, Kavan talked about quite related, but the quantum version of sort of the causal relation analysis, right?
Something like that. I think it was, I can't remember, but I think it was about connected networks and how they, the speed of quantum evolution in that case. But I didn't actually talk about the causality stuff that usually what I talk about.
Okay, all right.
And I think only two of us were speaking on that day.
Yeah, on that day. But after that, there was some kind of wine and cheese, and then I thought that maybe we can discuss potential collaboration and so on.
That was the first time I saw someone talking about ideas of consciousness from a quantitative perspective. So I was actually very surprised by that.
Yeah. And then after that, we started talking about potential collaboration through the interdisciplinary grant scheme within Monash. So that's a sort of nice side of the Monash. They at least at that time tried to facilitate this interdisciplinary research, right? And we failed a couple of times, but they eventually got it.
We got the network of excellence. So we failed at a couple other things. But network of excellence was a lot of money and it's nice.
Yeah, that one is the one. So that involved the Jakob Hoffy and so Tim Bain and the Kavan and me, and then we proposed to collect the nice people from New York and Singapore and London and another one I forgot. Wisconsin, Tononi group, right? So then try to invite those people, key people to Monash, and then let them spend a couple of months. That was for the postdoc, and also we had a 2-day workshop in Greece. And that's where we met.
Yes, that's right. Yes, that was a great workshop.
Yeah,
in the middle of a hurricane.
In the middle of a hurricane.
Yeah. Carl Freestone was there, and so Anil Seth was there from the neuroscience side, and so on. Yeah, and you also came to Melbourne 1 year before, right?
I believe so. I visited Kavan about a year before that.
Then didn't we have some kind of 1-day workshop in a city where Chalmers also gave a talk?
It might be a different.
Don't think you were.
No, I went to that visit.
That was a different.
I think you were supposed to come, but you couldn't.
Yes.
Felix Binder was here at the time.
Right.
Yes, they dumped some last minute center review thing on me.
That's right.
Yeah. Okay. But then after that event, I actually visited Singapore and then visited you.
Yes. Yes.
Yeah. And then there I talked about this, integrated information theory.
Yeah. That's right.
Right. So that's how we have met. And then maybe just briefly, can you tell us, what kind of potential projects that currently you are doing may be relevant for the audience who are interested in consciousness?
So the area that I'm looking at that I think probably the most interesting is related to notions of agents and strategies. I study what's the minimal resources that any consciousness, or any adaptive device really, but can need to execute a complex adaptive strategy. So I think about agents that interact with the environment and respond to that environment. And to execute complex strategies like play a game of chess or play a game of Go, or then the agent needs to remember events about what happened in the past to keep their strategic thinking coherent. And what I'm interested in is what's the minimal complexity of such a consciousness would need to be able to execute such complex strategies. And where the quantum comes in is I'm interested in whether or not a quantum agent is able to execute a strategy of a particular level of complexity using less resources or less memory than its classical counterparts. Or alternatively, if we constrain the complexity of a quantum agent versus a classical agent, would the quantum agent be able to execute more sophisticated strategies? So far, we've been looking at it in terms of fairly simple strategies like playing Space Invaders or playing a game of Pong. In these cases, you can kind of test how much memory you would need to execute such a strategy almost perfectly classically. And then we say, if we bring that level down, could the quantum still do better? Could the quantum do better than the classical counterpart when we have severely constrained constrained sort of memory structures? So that's I think the area where there is an overlap towards notions of thought and consciousness. But I guess.
What's the question again?
Like any kind of current project that you are doing or you're interested in, which could be interesting to share with this audience who are possibly mainly interested in consciousness.
Right. I would say there's no project as such at the moment, but I'm sort of trying to understand, is there a good way to pose the question of various questions of consciousness and agency and having some sort of a boundary. And I think I'm just interested in this for my own sake. And I guess in a way, the type of things that Mila was speaking about, the technical tools that I use are, well, they're identical. We use, both of us are working with these structures called quantum combs. And potentially one of the questions in quantum combs is that when you have two agents interacting, you have two different quantum combs interacting. They could also be classical combs, but then what defines that boundary? And that's sort of not so well known. There may be some thermodynamic implications there, because in strong coupling thermodynamics, you also have these issues of boundaries and how you might be able to define different agents. But I don't think I have any specific things in mind, but I want to, the type of things that I like to do in research, I like to figure out structures of problems. So one of the things that I've done is understood the structure of quantum stochastic processes. And this was a open problem for a long time because people didn't quite think about the problem in an operational way. I'm doing the same thing with quantum chaos at the moment. How do you construct structure of this? And possibly, if I'm lucky, it's possible to do that with agency / consciousness. But
I see. That's actually, although we think that there may be nothing to probably share, but independently, in a sense that we collaborated and wrote a paper once, right? Which is about application of the epsilon machine.
Right.
That all of us kind of share as an interest, which is sort of the minimum description of the dynamical system as a graphical model, and then apply that to the neural recording from flies under the anesthetized or wait for and that's actually been relatively well received in the field in fact.
Oh, right.
Yeah, actually, it seems to be doing okay.
It's also the Rob was invited to give a talk or the Monash physiology group.
Oh,
so
really?
they are
That's
interested
cool.
in the application of that. And then since then I've been mostly focusing on the structure, the problem of the structure actually. So independently after our collaboration kind of stopped, we kind of came on back to this similar question. So from my end, the question is about the structure of qualia, how we experience things. Like in the case of the color, seeing redness like this, you can't really define color itself. Right, you can't describe this beyond like, oh, this is similar to this bag or this chart or something like that. Similarity relationship can exist, but description of this itself, color quality itself.
If someone hasn't experienced red, then you can't really communicate.
Right. But my strategy is to relate this one particular qualia with another qualia in terms of similarity, for example, and then try to do it with different kind of qualia. Then in the case of color, we will have some kind of ring-like structure, which you may know, like red is similar to pink, but also similar to purple and so on, but very far from blue, green, right? But it's from the sort of physical perspective, it's not that obvious why this has to be like a ring structure.
Yes, because in physics you just have a frequency space.
And purple and red is opposite.
Yes.
Right.
So it's a bit strange that they use this link between purple and red.
Right.
From that perspective.
But to interject, but couldn't you do the same in the sense that suppose I give you a bunch of shapes and then I can connect them to colors and make similarity. I mean, so maybe we see the similarities between shapes in a more transparent way than we do with colors because of the way we experience.
So this kind of experiment has been done in psychology, in the shape space as well, and many things has been known. Like one of the important insight is a so-called category. Right. Like if you continuously deform things, you tend to experience something up to here as almost identical or same, but there is some kind of interjection, huge jump, and then you see.
Right, so there's some phase transition where suddenly the human brain starts interpreting it very differently.
Right.
Like it looks almost the same to us, almost the same, and suddenly there's a place where the parameter changes there's a fairly small perturbation, but suddenly we feel like it changes a lot from our qualitative.
Exactly.
I see.
And then, so characterizing something like that, qualia or consciousness in that domain first as a structure, and then also look at the brain's informational structure, and then try to link between these two structures. That's sort of the approach.
So imagine is it something like we expect that our neural impulses, electric signals in our brain to be fairly similar if we when we see these colors, but as we put up that parameter over the threshold, our brain responds very differently.
Categorical.
So this is what you want to see. Or
that's to some extent done, but it's all that's like a sort of unidimensional kind of description and understanding, right? But what I want to do is more sort of higher dimensional. Like in the case of the color, it's starting to become like 2-dimensional, and if you add the luminance, it becomes 3-dimensional. And also, more important thing is that the counterfactual relations, right? Like red. When you see red itself, you don't really directly compare with the green, but you can always compare that with the green. So that kind of relations are the fundamental thing to describe structure. That's the sort of the idea. I guess, the way I'm not sure how you are trying to kind of, address the structure problem from the, like, you say the quantum stochastic structure or quantum chaos structure. I'm curious how you're going to deal with this.
I guess the way you're looking at it is the structure from the inside. It's somehow the perception. What I'm curious about is how did the ideas of perception even come about, or agency or consciousness, and so for that I want to understand the structure of interactions, and that's more from the outside. It would be more about you're an agent, I'm an agent, the three of us are interacting. What does that space look like, and why is that bag not an agent in this? What did all these inanimate objects look like?
Well, that's actually quite interesting and also relevant to my fundamental kind of idea. So it's coming from category theory. There is a very interesting lemma called the Yoneda lemma. And what it says is that all the things that you can know about anything is already there in its relationship with others.
Right.
So we tend to separate the intrinsic property and extrinsic relation to others, but according to this theory, as long as things are considered to form a category in the mathematical sense, then all the relations to other objects.
That seems like the same idea as the Markov blanket idea. That you have. It seems to be right.
So I didn't think about that way.
So Markov blanket says that you have this something in some space, closed space, right? And then everything inside is defined or can be understood in terms of its relationship with the external world. The arrows going in, the arrows coming out, the information they may retain. And so the boundary determines the bulk, which is holography in physics, right? And that's a very important principle in modern physics, in field theories and general theory of relativity. So it's a powerful idea that, and in the sense that this object, the light, the sound, the way it bounces off it, the way you might interact with it, that already defines that object.
Exactly.
Right. It's very physical.
Yeah.
The lemma is very physical in a sense, right?
Yeah. And I thought that, well, one of the topics I wanted to also discuss or hear about, hear from you guys today is the idea of the relational interpretation of the quantum physics proposed by Kavan, right? You guys are familiar with this, or?
I've heard of it.
I've heard of it, but I can't say I've read too much into it.
I see.
Didn't you have some dealings with Carlo?
We went to the same conference.
Oh, okay. No, I never met the guys.
Oh, the SQXR?
Yes, SQXR.
Oh, okay.
Yeah, you didn't make it, right. But we went.
Yes, we went to,
Yeah.
Jane actually had the same panel or something. Yeah.
Right.
Yeah, I didn't have a super good impression when I heard his talk, or when I met him really briefly. I think I chat now, but when I read his book Helgoran, that's a new book, and it's actually translated in Japanese really well. And the title of the book is that the world is made of relations. So in that book, it's quite philosophical, but he says, for example, all the properties, physical properties are relational.
Yeah.
Yes, that one can probably.
Which is
make that argument.
sort of the structure that I'm interested in.
I see.
Right, because that's how we all interact with each other.
Right.
I mean, and I think in the basis of, if you look at information theory, information only makes sense when it's correlated.
Exactly.
Like when you say, I have information about, like if I just say I have a 1 or 0, that 1 or 0, unless that 1 signifies something, and 0 signifies something else, so I don't actually have information.
Right.
I think this is something. I mean, we have measures of information that don't really talk about what they signify. But in actuality, all information should be classified as really neutral information, which is how much information it has about something else. Because you know, I can say I have this book and it says 20 bits of information, but that itself, you know, doesn't say anything unless each bit corresponds to some notion of some reality. Like by reading it, I need to infer something about the environment for it to actually have information, or that is just randomness. So in actuality, information
Like
theory
reading a book in some other language is pure randomness.
Precisely. So I think this is something that is often underappreciated, but actually information has to be correlated with something else to be meaningful.
Yes.
And
well, sort of, right? I mean,
otherwise, I guess there is still the thermodynamic stuff. You can still, that's randomness. It's you don't know anything about it, but I mean, it's entropic interpretation.
But deciphering coded information, the task is precisely to make the correlations. In other words, you intercept a Nazi message, and you know what they're gonna sign off with. So you figure out what's being used.
That is absolutely true. I guess in that case, I mean, the messages that you want to decode has some correspondence with something in reality.
Absolutely.
So in the end, one still wants to decipher the mutual information with respect to something else.
That's right.
And so the information you want to get out is always correlated with something.
If anything, that exemplifies what you're saying.
One really needs information to be about something. I think this is quite important. In relation to sort of the stuff about qualia, I mean, one of the things that I suppose what I look at is, as I mentioned, these agents, and they're supposed to perform. I mean, one of the goals of agents, at least in machine learning, is the ability to maximize some utility function. So this could be the survival rate, something sort of in nature, like how well they replicate, but it could also be an artificially implied thing, like in Space Invaders, their high score. But once one has that sort of performance, then you ask what these agents are, if they want to have a fairly simple structure and still be able to perform well, then they naturally need to categorize the environment into internal memory states so that they can perform well. And this, I think, like if you say there is some sort of cost in having structure, which usually one supposes because it's fighting against the second law and so on, then one would say that you want a minimal structure and still be able to execute the strategy that would imply success. And that I think naturally have a pressure to start doing these categorizations. So for example, if it's very important to distinguish the color red from the color purple or the color blue, then they need to be mapped into distinct memory states. And you might argue that these memory states are experienced as qualia because that's the internal consciousness chooses to distinguish them. So that they can perform different actions depending on their perceptions. So in this sense, one may perhaps one could argue that these phase transitions could, I suppose, emerge because there are certain areas where it's more important to distinguish things than others. And then naturally, from our evolutionary pressure, the successful agents end up having roughly those areas where they choose to make that distinction.
Well, I roughly agree with what you said, and but I also want to raise one thing. The specific type of the relation, the specific type of the information, or specific type of the categorization memory will probably correspond to specific type of the query. And what exactly it is or why this has to be related in that way, that's a really unclear thing, right?
Yes, absolutely.
But another thing about I always think these days is this, the concept of maximization in general. This is also related to the kind of the leadership or administration kind of issue that we talked about just in a couple of minutes ago at the coffee shop. But I think whenever any kind of physical entity forms an ultra structure or forming some kind of combination, then the maximization of something starts to become very difficult and even, competing with each other, right?
Yes.
Like in the case of the leadership, like, us kind of, professor level person wants to, promote ourselves and succeed as a scientist, as an individual. And that, kind of goal easily conflict with what the university as a whole wants to do, right? So in this case, do you think that in general, any kind of maximization or utility exists for this structure of the Monash University? I don't think that's probably the case.
I agree with you.
Yeah.
So an agent individually, if you consider to be living in a kind of a fixed environment, you can think about it optimizing its own utility. But when you're describing this in this situation, what we have is many different agents, each with their own utility function of what they want to improve. And it becomes a very complex multi-agent interactive system.
Yeah.
And global maximization of that is difficult to even define. I mean, but one could still, of course, study the system in terms of local optimization of each one of the individual agents, and that leads you to game theory, Nash equilibriums, and so forth. In terms of, agents want to maximize their own, what they value their own, and then they have to take into account what other agents do.
Yeah.
And perhaps they will reach some sort of Nash equilibrium where locally each individual agents varying their strategies will only do worse.
Yeah.
But of course, agents are not necessarily rational in the human world, so you may not be at Nash equilibrium.
If you make it even a physical problem, so let's imagine no agency, right? Take agency out. So now take the problem and make it a problem about the positioning of Earth, Mars, and Jupiter. Now, of course, there's all sorts of other stuff out there, so it becomes an open system, and we know that this is a problem that is not solvable. The three-body problem is not solvable.
Right.
Now, if Earth, depending on its current position and velocity, makes a decision, right, internally computes something, and Mars and Jupiter do the same, then you're and you're not privy to that information, then it becomes an impossibility to even predict what will happen because you don't have all the physical parameters defined. So it's a three-body problem that has a time dependency. So that's an impossibility. It's a worse impossibility.
And inherently, if you go down to the quantum level, there is also some kind of indeterminacy, right? So
no, I would avoid that, right? Because we can actually do everything deterministically in quantum mechanics. Only, and by the way, this is one of the reasons why quantum physicists are always interested in agency, because quantum mechanics is all deterministic and all lovely until the experimentalists have to come in and do experiments, and then it becomes indeterminate. But we tend to avoid that until we have to. But we don't understand why the agent. Why there must be an agent in quantum mechanics.
So maybe then let me sort of state my version of the interpretation of Carlo Rovelli's position, right? So he thinks that the agent or conscious agent or experiment shouldn't be considered as special. So according to him, any kind of the relations or interaction between particles would already qualify as an observation or measurement and things like that.
I think that's very popular in many world interpretation of quantum mechanics already.
But he also argues against the many world interpretation, so that's actually interesting thing too.
I'm pretty sure someone said that Carlo's interpretation is many world in disguise. So I'm pretty sure I've heard that, but I don't know it.
He's quite critical about many word interpretation. But anyway, what he says is that some kind of property exists in relation to others, and that appears to this thing only from this perspective. So according to his explanation, if I understand correctly, the Schrodinger's cat is either living or dead, completely determined from the cat's own perspective. But before I interact to measure this or observe this, it can be superimposed, but that's a kind of status, and then but the property becomes completely determined when I interact with the system, right? So that it's a relation that determines.
It does sound a bit like many worlds interpretation in the stars.
Yeah, I'm looking at the Wikipedia. But look, I think that people tend to pose this quantum measurement problem. They think that quantum measurement problem is very fundamental. It is fundamental. It has nothing to do with quantum mechanics, at least in my opinion, right? Descartes was struggling with this, right? How do you explain a mechanical world with an individual who has their own agency independent of that mechanical world, right? I mean, I think therefore I am. It's sort of trying to make sense of that. Quantum mechanics only makes the problem unavoidable in the sense that now physics doesn't even make sense if you don't ascribe agency.
Yes.
Descartes could, potentially you can get away with that by putting that under the carpet and say everything is mechanical and this is all emergent. But now it's not even a possibility because you need that agency to make that choice and then Bell inequalities and all of that. How do you make sense of it? I mean, one way to do is superdeterminism. Everything is, all of this is illusion, and everything is quantum mechanical. And
the world is a unitary.
World is unitary. I was first very critical of, or thought very critically of Penrose's idea, but I think it's pretty nonsensical on one level, but I think it's pretty interesting on another level. And the gist of that idea is that there is something inherently non-quantum mechanical happening in your brain that gives you randomness, which is enough. You just need a bit of randomness to get agency. Now, why it happens in the brain? Well, it probably doesn't. It's probably right. It probably happens everywhere, and that some things use that randomness of the universe, that the non-quantum mechanical part of the universe to do something with. We're using that randomness for our agency, but which is actually a brilliant idea. I don't think it has anything to do with microtubulars. Maybe it does, but probably not.
Probably not.
I see.
It is very difficult to reconcile because at one hand, I mean, we don't have any evidence that counteracts quantum mechanics. So it's very tempting, in a way, to say, very elegant to say that the world is quantum mechanical, everything is unitary. But at the same time, I think most people would have a problem in sacrificing the notion of some notion of agency, because we do, at least from a psychological perspective, like to think that we make certain choices. And indeed, if we did take superdeterminism to extreme, then a lot of experiments wouldn't even make sense. They wouldn't even prove anything. Bell inequalities, for example, wouldn't really prove anything because it requires free choice of the measurement observers. And if everything was in fact unitary, then we can't really do any experiments. Because experiments require us to be able to start in the same conditions and make different choices on how to do the experiment. That's the entire basis of the scientific method. We have control, and we have so that we can compare our hypothesis with control. If everything was super deterministic, that itself, the control and the hypothesis will have to be correlated.
Determined.
Yeah, and everything's determined. So in fact, super determinism itself makes a scientific method untenable. And so as scientists, it's very hard to say, okay, I really believe in super determinism. But at the same time, quantum mechanics haven't shown us any evidence against superdeterminism. And this, I think, is a big issue.
And on the other hand, you have panpsychism, which, panpsychism and superdeterminism seem like very, the opposite extremes, right?
Everything
you
is,
can't take either of them seriously. We live in somewhere in the middle, and it's amazing that we live somewhere in the middle.
Okay, but maybe I want to take one sort of the issue from sort of psychological or neuroscientific point of view, which also potentially relates to sort of religious or kind of interesting philosophical idea. But when you guys talk about the agency, which is probably potentially quite surprising to some of the audience, physicists talking about the agency, right? But anyway,
don't have a choice, so that's what
I have to say that
in
fact, physicists are probably one of the first people to very much think very seriously of agency. Because agents actually have a long history with physics. Of course, from metaphysics already we have people like Descartes, but from actual quantitative physics, I think from the time of Maxwell's demons, agents had to be seriously considered long before quantum mechanics.
I think even before then, right? I mean, Descartes and the philosophers back then dilemma with
I agree.
mechanical world and
so this is a metaphysics. So from the ancient philosophers of physics had to grapple with this idea of the autonomous universe versus the ability for humans to make their choices. And I think this has been a deep philosophical question ever since people thought seriously about describing reality in any sort of mechanistic manner. I think as you go towards modern physics, once people started grappling with things like Maxwell's demons, which is the idea that somehow people thought about, normally everything like the second law of thermodynamics says everything gets messier and messier, and so if you kind of the classical intuitions, you leave a room, if all your gas molecules are on one side of the room, then you let them bounce around, eventually they're equally distributed. If you start off with your room that's very messy, very clean, very tidy, eventually it gets messy without you doing extra work to clean it up. The second law permeates everywhere. And initially, people thought that agents seem to violate that second law. So Maxwell's demon was a classic example where they said that, okay, look, you have a box with equal temperature, but now you imagine the demon could look at every individual molecule, and if it's fast, move it to one side, putting a partition. If it's slow, keep it on the other. And then eventually you'll have two partitions of the box. So one side has very fast moving molecules, which means it's very hot. And the other side is very slow moving molecules, which is very cold. And it looks like a spontaneous way of basically separating something of a warm temperature to hot and cold, which then you can recombine to create a heat engine and get kind of work out for free, like a perpetual motion machine. So somehow at that stage, people thought that the ability to have agency can allow us to essentially get
it's a powerful resource.
It's a very powerful resource. It seems to allow us to get free work, perpetual motion machine. And on the other hand, also people sort of like these biological systems, somehow spontaneously evolution has created structure, and somehow in a local violation of the second law, which says that structure degrades, but somehow life has created more structure. Consciousness is highly structured, like how did it evolve from the randomness of gases? And so in a sense, there has always been this notion that somehow agency allows us to somehow supersede these statistical second laws. So I think from that very moment on, people have physicists were forced to confront agency. And of course, now we have better ideas, we have information theory, we understand that agents themselves need to pay a price, thermodynamic price, to clean things up. So in a sense, they can't really violate the second law. But in doing so, Maxwell's demons and stuff were the first mechanical agents that people sort of considered. What happens when we embed agents in the physical world and describe them by physical laws? So quantum mechanics is just further forced us to confront it, to really think about agents in the context of how it relates with physics. And we still haven't grappled all the finer conflicts.
I see. Okay, that sounds great. And maybe can I propose to have a break at this point?
Sure.
Yeah.
As agents, we need to eat.
Yeah, and also I still have some questions about that. So it's a good place to stop and then restart.